Okay, so let's start. Topic for today is building ETL microservices using Kafka for fast big data. And in particular, in this presentation, I will show you how you can use DataTorrent AppFactory to build apps with low time to value. I mean, let's start our journey, and you will at the end of session you will realize how fast you can develop your first cut application, and from that you can jumpstart your actual use case. So agenda for today is first I will briefly cover why do we need microservices, and how typically organizations build architecture with Kafka, or for that matter any message bus as a backbone, and build microservices around it. And then we will cover some typical challenges which are faced when you develop big data ETL pipeline. And then I will introduce the AppFactory developed by DataTorrent, which will help you to build your own pipelines in speedy manner. Okay, and finally I will show you the demonstration where I will show you some simple application which shows how you can use this microservices architecture to deploy your applications. So let's take some sample example. So this is sort of a use case from insurance domain, and this is just for illustration. So whatever arrows you can see, you might have more dependencies, or you might say that some arrows are redundant depending on your own views. But just for illustration, let's say that there is some user interface component, and that is served by some UI service layer, and then there could be some component which is payment gateway integration, and there could be some component which is doing the actual new orders or renewal orders servicing, and then there could be some component which is deciding on discounts, offers, and stuff like that, or there could be some which is dealing with partners and paying them the commission and so on. Like, so if we look at this system as set of components, we can see that many of the components are interdependent, right? And if we want to establish some communication channel between these individual components, then there are too many arrows or dependencies going around, and it becomes hard to manage. So the alternative way to design this could be like, you can have a common message bus, and you can say that each component will read from this message bus, do whatever processing it wants, and write back to this message bus. And this greatly simplifies your architecture, right? So the same use case we're trying to map to the microservices architecture with a common message bus in between. In particular, you can have a message bus with Kafka, or you can choose to use some other message buses like let's say RabbitMQ, depending on your requirements. So there are pros and cons on choosing one versus other, which we don't want to get into, but definitely we agree that there will be some message bus, and there will be some services or applications or components or modules, whatever you want to call it. But basically some independent components are running, and those are now separated with a common message bus, which is doing the job of transferring data from one component to other, right? So if we use Kafka, let's say, then it will be like each component will decide on some topics. So that component might say that, okay, I will read data from some particular topic 1 and do some sort of predefined processing, and I will write my output to so and so topic. If some other component is expecting that output to be read as its input, it can subscribe to that particular topic, and then it will get those messages as soon as those are published by the application one, right? So if we want to make this generic, we can say that there are n number of services running, and there is some message bus in between, and each service will have sort of predefined topic on which it will read data from and write data to. Okay, so when we talk about, so this was all about microservice architecture and why do we need it and typically how it is done, right? Now let's move on to big data ETL. So when we say big data ETL, typically, what we mean is, basically you're reading data from some source stream, you're parsing it, cleansing it, filtering, transformations, aggregation. There could be some custom computations which are not, part of the standard aggregation functions. So you might write some custom aggregators for that. And finally, you will write results to some stores, right? And then you want these stores to be, depending on your need. So it could be like you want to fire some ad hoc queries to the store, so you might choose one store over other. Or, if you want it to be archived in cloud, you might choose stores like S3 or Azure Blob Store. Or, if you want to, just retain in on-premise, then you might just, if it is just for archival, you can simply write it to HDFS. So there are different ways in which, each ETL pipeline is designed based on the requirements of a particular use case. But these are sort of, common, you can say, functional specifications for a typical big data ETL, right? So these are the components of functional design, and most of you will agree that more or less when we mean ETL, we typically do these things, right? Now let's come to the operational part of the same ETL pipeline. So when we talked about functional specs in the previous slide, we described what all things are needed, right? But those are just the functional things. When we look at the operational things, there are a lot more things to be handled. For example, we just say that, I want to read data from X and write data to Y, but it inherently means that I want to have parallel read, parallel write, because we are talking about big data. We are talking about distributed systems, right? So parallel read, parallel writes are somehow you can say a must-have part or inherent part of the specifications. Then there could be some skew in your input data. So if you're doing some partitioning, there could be like one partitioning is getting a lot more data than the other partition, and then that might become the bottleneck. So you need to identify such skew, right? Then you will need sort of multi-tenancy feature where you deploy multiple such applications which will run in parallel, and then there should be some mechanism to do the fair scheduling of them, and it should not happen that one job is getting starved because of the other jobs and stuff like that, right? And then there are n number of things. I don't want to get into the details of each, but when you talk about integration with current monitoring, let's say, so you will have some monitoring console which your DevOps team is looking at, and basically when you develop a new application, you want to integrate that with the existing monitoring tool, right? So you will need sort of some web services which can expose the metrics on the REST APIs or some API which your monitoring system can identify, right? Or obviously you need to do proper error handling, or you need to have provisioning for fault tolerance, node outages, and stuff like that, right? Or you might want to, for audit purpose, you might need the intermediate results or data lineage. You you will need API compatibility, like the versioning. So for example, if you upgrade to the new version of the same platform, it should not break your application, right? Existing application, right? So these are sort of operational specs, and typically what we have observed with our experience is, the functional design takes, less than 20% of efforts. Actually, I'm quoting 20% to be on conservative side. Actually, it's even less than 10%, I would say, right? And most of the time it's spent in operational aspect. So it really depends on, how operable your platform is and how your platform is out this operational, you can say, operational challenges for the app developers, right? And this was the main proposition for developing Apache Apex project. So our idea was, application developers should just focus on the functional design, whereas platform will take care of operational aspect. So let's take some example, okay? So for example, let's say fault tolerance, okay? Everyone wants to have their application to be fault tolerant, okay? And there are ways to handle it, right? For example, you might want to, maintain state of your application periodically. Now, some platform might say that, okay, here is a hook to the application developer, and you can write your own code to save your state and do whatever you want. But then what happens is, the boilerplate code, maintaining the boilerplate code headache comes to the app developer. Whereas in case of Apex, what we say is platform will take care of maintaining the state of your application. So, app developer is freed up from that responsibility. He can just focus on the core business logic, right? And that's the main advantage. That's what we mean by when we say that the platform will take care of the operational aspects, right? And then we have, simple interfaces and APIs. So there is a low barrier to entry. So for example, some other platform might, ask to learn, functional programming or things like Scala or Python to get into the big data. But what we realized, vast majority of the developers are not from that background. They don't understand functional programming or Scala, but we get, large pool of Java developers. So our platform allows any Java developer to jumpstart on developing big data applications, okay? Because our APIs are simple, those are, so we call them as, compositional APIs. So rather than, declarative APIs where you just have, high level APIs which defines, what needs to be done, and, the abstraction is, hides everything below it. We believe in compositional API, which gives very fine-grained control to the application program, right? And then we have rich set of operator libraries for common operations. So things like whatever we described in the functional design, for example, reading from some source, parsing, filtering, transformation, writing to some store, aggregation, deduplication. We have large set of operator library which provides this functionality out of the box. So what you need to do is configure that operator in a right way and use it in your application. So this will in effect reduce your time to develop and time to market. And that's what the goal of every data engineer, right? They want their application to be pushed to market as soon as possible, right? So, this is a typical slide which covers almost, many questions which gets asked in a webinar. So It explains where does it fit in. Okay, so as you can see the blue box in the middle, right? So you can see the DataTorrent or the Apache Apex engine is actually a stream processing engine. Okay, so it can do all sort of stuff like reading data, transforming data, doing custom computations, filtering, and so on. But it's not really, you can say there is no store over here, or there is no, you can say, a message bus and things like that. So what we have done is like we rely on some, message serving layer. So in this case, it could be Kafka because we are talking about microservices architecture, but there could be some other systems by which you can get in your data, right? And your data is originally getting produced from something like, web server logs or click streams or sensor data and whatever, right? Ultimately, it lands in some sort of message serving layer, and Apex pulls data from this message serving layer. It does all the computations needed, and finally you can store the results in whatever desired store, right? In this case, we will be writing back to Kafka because we expect that there could be some other application which is reading back from Kafka, right? And then there are real-time analytics and visualizations which are off-the-shelf provided by the DataTorrent. Or you can as well use, data visualization tools like Tableau or some by pointing to these stores, right? So if you have your visualization tool which is already chosen as part of your data pipeline, you can keep it intact, and you can just, write to the appropriate store which will serve the request to your visualization tool. Okay, so here is an example. So whatever we described earlier, let's say we have n number of services. So here I'm trying to demonstrate or call out some examples of services. So it could be like you can have, let's say, you might have a data cleansing app which is just doing the cleansing of data. Then there could be another app which is doing just feature extraction, which is like, so I have maybe, 20-25 fields from my raw data, but I want to, add some custom fields which are sort of derived fields, and then, then it will become sort of 100 fields, and those becomes feature for my machine learning models, maybe, right? So there could be another pipeline which is doing the model training for machine learning, right? Or there could be, some application which is just for data archival, which we said earlier, as we said earlier, it could be for auditing purpose, right? You might want to retain data over SDFS or S3, or you might write it to Cassandra and say that, I will use this NoSQL database for, whatever queries I need for dashboarding. Or there could be another application which is just for monitoring and alerting, right? So it is not really the same as the DevOps alerting. It could be like, even business alerting. For example, if your inventory is, going out of stock, you should get that alert immediately, right? So there are like a number of pipelines, and we define sort of some common message bus and define some predefined topics on which we can read data from and write data to. So we described about DataTorrent platform or Apache Apex, and so actually if we look at overall layers to use this to develop your ETL pipelines, it could be as follows. So at the bottommost layer, you will have a Hadoop cluster. So we need a Hadoop 2.x cluster, and basically what we need is yarn plus HDFS. So it could be on premise or cloud. So and we are agnostic about Hadoop distribution. So you can have Hortonworks, Cloud Data, or you can have, cloud infrastructure like AWS, Azure, or your own cloud provider, you know. So any Hadoop 2.x is fine for us, and on top of it, there'll be Apache Apex core engine running, and then on top of it, you can see that we provide operator library, which we call it as malloc library. And then there are some, predefined application templates. So for example, right now I will show you the demonstration for Kafka to Kafka application template, which is basically reading data from Kafka, doing some custom processing, and then writing back to Kafka. And when we talk about microservices architecture, this is typically your flow, right? So what we need to do is, take this application and run it, and then then we have sort of skeleton application which is already ready, right? Then what you need to do is customize this application to suit your use case, because the schema will be specific to your use case, or what operations needs to be done is specific to your use case. But what is common is sort of the operational aspect of all the ETL pipelines is taken care of by the platform. As well as by defining the application template, we also give you the skeleton application, right? So you can think of it as, maybe the real world analogy to this could be, you can think of it as you're going to the IKEA store and, getting the assembly for a particular unit which you want to have, and then you assemble it on your own, right? So similarly, you will get the skeleton over here, and then you just customize it based on your need, right? So it significantly reduces your efforts, right? And on top of this, you will get, you know, the there are other toolings provided to enhance your experience. So it's like you will get the real-time data visualization, management, and monitoring tool, the application assembly user interface, and so ready ETL pipelines and stuff like that. I talked about operator library earlier, so let me give you some list on that. So this is not the exhaustive list, but it covers the major things which we support. So on the messaging side, you could read it or write it to Kafka, Solace, Bloom, and parser. We support various popular formats like XML, JSON, CSV, Avro, Parquet, and then there is a bunch of NoSQL databases like Cassandra or CouchDB, Mongo, and so on. And then there could be inverted index technologies like Solar, Elasticsearch, and stuff. Then there could be other protocols like HTTP, MQTT, SMTP, and so on and so on. Or you could read it and write to traditional databases, or then there could be transformations like filtering, enrichment, deduplication, and so on. So this shows monitoring console where you can see so this I think I will cover as a part of live demo as well, but you can see you can see the application, you can say the block diagram of your application, which we call it as a DAG or directed acyclic graph. You can see all the metrics needed for monitoring your application. So it will show you how many containers, how many tuples getting processed per second, and so on. We also provide a rich set of customizable dashboards. So for each application, you can build such dashboards. And finally coming to the AppFactory part of it. So as I said earlier, it's sort of do-it-yourself apps, right? So what we provide is skeleton application or a template application, and you can customize it to solve your use case. Okay. So how does it help to reduce your time to value? You know, so if we look at, writing your, so we already looked at, if you start writing big data ETL pipelines on your own, it will be from scratch, then it will be significantly difficult, right? Because you need to handle even the operational challenges on your own. That's next to, very hard problem. Not next to impossible, but definitely a very hard problem. And why should you write it from scratch when there are, platforms which takes care of it, right? And what we claim is Apache Apex is built keeping the operability in mind, and it will reduce your headache of maintaining the operational challenges. Okay. And so, the next logical step is, you decide on the right choice of the platform, and then you build applications or your own, right? So on the left side, we can see, writing your own applications. It's the next step. But, even simplifying it further, on the right side, we can see the application templates where, you will get a skeleton application, which is, already you can say you just need to configure it and launch it. So which is sort of pre-staged application, which can be launched. Okay. And so there is a low learning curve because a typical developer will get some confidence when he sees something up and running, and then once he gains the confidence, he can go ahead and customize the application, right? And this is the cycle which we stress on. You can just use our tutorial videos and documentation, import the application, configure it, and run it. And then you can make changes, test it, improve it, again make changes, test it, improve it, and you can continue this cycle until your entire use case is satisfied. But what's important is, getting to the first running version of the application, and that's significantly simplified with this AppFactory application templates. So this is the website datatorrent.com/appfactory, which gives which shows you different verticals in which you can see these applications. And in particular, if you go to some specific vertical, so for example, on the right side you can see Kafka to Kafka filter transform application. So this is listed under, I think, the IT vertical right now. Okay. And yeah, so these are the pointers for writing to getting more resources on the AppFactory front. Now let's go to the live demo part. So I will be starting the services. In the meantime, I will walk you through the documentation which we have, and we will be using this documentation. Okay, so this is a website for docs.datatorrent.com, and over here you can see the app templates documentation, and it gives you detailed instructions on how to import and launch an app template. Okay, and then here it gives the steps how to customize your app template. Okay. So let's check what is the input data. As you can see, there is no data on this particular topic as of now. Okay, just give me a minute. Okay, so sorry about the interruption, but yeah, now we have Okay, so sorry about the interruption, but yeah, so I have pushed some messages on the input topic, and so you can see some JSON messages over here, and it's like the schema is basically some policy number, and then some customer name, and some premium amount. Okay, and yeah, and now let's launch the application. So let's say I will go to the AppFactory page. You can see, as we discussed in the slides, you can see different verticals over here, right? Let's go into the IT. It shows different sort of application suites available. Let's say continuous big data preparation, and here you can see Kafka to Kafka filter transform, right? So it describes what this application is doing, some block diagram, and it also gives the resources like GitHub link and the detailed documentation and things like that. So let's quickly import this application. As I said earlier, the main steps are, first you download the DataTorrent RTS installation, and then, these applications are listed inside RTS installation. And what you need to do is import these applications, configure them, and launch them. So I have sort of predefined inputs listed for my application, which I will be using. So this import will take some time. Sorry guys, looks like there is some network problem, and which is causing more than expected time for import, but bear with us for some time. So in the meantime, I will explain you about the inputs. So for this application, what it will ask for is basically, since we are doing filtering, it will ask for, what is the filtering condition. Then it will ask for what is the topic name on the output side. So we are saying webinar test output. Then it will ask for field info for passing. So we are saying we have 3 fields, mainly the policy number, customer name, and premium. Then it will ask for Kafka broker list. So we are saying I am running Kafka on localhost 9092 port. Then it will ask for the input topic name. In our case, it's webinar test input. And then Kafka producer properties, which is for writing to the Kafka topic. So there we need to specify the serializer class and the broker list and so on. And then we are doing some transformation. So we are doing here, just for illustration, some simple transformation, which is just we are just taking this customer name and trying to capitalize it. So it says that, whatever is the current tuple, you just take get customer name and do the 2 uppercase. Okay, we'll just see what is the progress on our import. Yeah, it is still in progress, so let it be. I will first cover this, and then yeah, so for output field info, it's like in my output purview, what are the fields I'm expecting, and then you specify initial offset, which could be earliest, or if you're doing it from beginning, then you specify it as earliest. If otherwise, you specify it as latest, so that you won't get the previous data, you will just get the latest data after you launch the application. Right, so this is the gist of parameters which are required to launch this application, which will be needed at the configuration stage. And now looks like import is taking some time, so I will show you the alternate way of doing the same. Okay, so here is sort of application packages. I go to that and I say upload package. Now I have checked out the code for this particular app template in my local system, and you can as well do that, because as we have seen in the documentation, it had linked to the GitHub repository from where you can clone this code and check out it on your own machine, and then you do the maven build, which will generate this .apa file. Okay, I will choose this file and upload it. And now, since I'm uploading it from local machine, it will be significantly faster. When we are trying to import it, it was from the central repository over the internet, and because of some internet issues, we were taking a lot of time. Now this is imported. As you can see, it's imported 7 seconds ago. I'm saying launch this application, and now it is showing the launch dialog with whatever fields we described earlier. Now I will just populate these values. Now this is my Kafka Broker. This is my input topic name. These are the properties for the producer. These are the expression info for transform. And these are the output fields. Let's see. So here we'll be adding the earliest instead of latest. And yeah, since we are doing it locally, let's add 2 more properties, which is controlling the memory. So this one is saying that how big should be my buffer for each operator, which I'm specifying as 128 MB, and how big should be the container. We are saying it to be 512 MB. You can see that application is launched. The application will be in accepted state first. First, it will, request a yarn for resources, the containers, and okay, so the error was for the import, which was not successful. So anyway, we'll ignore that, but we'll concentrate on the current application. As you can see, it has already processed 200 messages from Kafka. Then JSON parser has parsed those messages. We have applied the filtering condition, and from that, some records where, did not satisfy the filtering criteria, so they went on this port, and those which satisfied went on for the transformation operator. Okay, and for this we are just doing the count of what are the filtered tuples and emitting on the console, whereas for the successful transformed tuples, we are again doing the JSON formatting from the Java objects or POJOs, and then writing them back to the Kafka output. Okay, so this is the monitoring UI which I was talking about. You can see the counts of total number of tuples processed and what is the latency for each operator, and how many containers are we using, and then there is a physical view which points to the actual containers, and then you can look at the logs for a particular container. So this is very useful for debugging, and so there are n features provided in this platform, RTS platform. Let's now look at the output side, and what we expect is there will be some filtering based on our filtering rule, where we are saying that the premium amount should be at least 50,000. So some premiums where it is lesser than 50,000 will get rejected, and other premiums will be shortlisted. For example, this record should be rejected, right? Let's look at the output. As we can see, the names are capitalized and a few records are rejected, and we can see records only for the premium amount greater than 50,000, and you can see there is some remap for the fields, which is because JSON is it ignores the ordering basically, right? So JSON formatter might decide its own ordering, so it is not retaining its original formatting. Okay, so that's what about the demonstration. So actually I had a few more points for demonstration, but since we are lagging behind the schedule, I won't go into the phase 2 of demonstration, which is how to customize this application. But I will just show you the quick pointer. So here it is. If you go to docs.datatorrent.com, here it gives clear steps on how to customize this application. Okay, so sorry, we faced some technical challenges, glitches in between, and so we could not take this as a part of presentation. But I will stop over here and wait for a few questions, if any, and after that we will close the session. So yeah, time is for you to bring up your questions. You can type your questions in the questions tab, and in the meantime, I will go back to the slide and just show you the resources slide, which has most of the links. Yeah, so here are some links like for our documentation, for our YouTube channel, for our meetup page, SlideShare video, SlideShare channel, where you will, please understand that these slides will be uploaded on SlideShare and video recordings will be shared on YouTube. So, and so there is ample material available already from our previous sessions like workshops, tutorials, webinars, meetups, and so on these SlideShares and video channels, right? And the most important pointer is for DataTorrent AppFactory, which is datatorrent.com/AppFactory, where you get the application templates. And then, we have special startup accelerator program where, if you meet some conditions based on, your operational revenue and the funding you have raised, you can, define your organization as startup if it is below that threshold, and you will get the free enterprise license for startup. Okay, and apart from that, we have a sort of free trial version for the DataTorrent RTS tool, and you can use it for evaluation. And if you like the tool, and if you want to go to production with this particular product, then there could be discussions on the licensing fees and stuff like that. But typically, our licensing model is based on amount of memory you're using in your cluster. So if you're building, very big application, it will require, more memory footprint and it will have those cost implications. But, our tool is free up to certain memory usage. So that's all from my side, and I will wait for 2-3 more minutes to take more questions. And there was one question regarding the licensing, and I tried to answer that right away. That's all, I think. So thank you. Thanks for joining us and spending your precious time with us. And I hope you like this presentation and demo, and you will certainly consider Apache Apex or DataTorrent RDS as one of the key evaluation platforms for your building your ETL pipelines. And I'm confident that if you're looking from the operability perspective, then you will definitely give more weightage to Apex. Thank you.